Okay, so on this example, it says, on average, a banana will last 6.9 days from the time it is purchased in the store to the time it is too rotten to eat. 6.9 days. Is the mean time to spoil greater if the banana is hung from the ceiling? Does that help it? I think it does. I think we have a little hanger thing my wife bought, so I think that makes them last longer. The data show results of an experiment with 13 bananas that are hung from the ceiling. Assume the distribution of the population is normal. So here we have 13 bananas and how long they lasted when they were hung from the ceiling. What could be concluded at the alpha 0.1 level of significance? Okay. So how we can do this? Well, let's go to the notes. So here we are. I'm in the unit 3 notes, page 2, hypothesis testing. Do we have a percentage question or a mean average? It's an average. Did you notice that? So right here it's saying, it says, what does it say? On average, it's the second word. That's how long they last, right? It's an average question. So we go back, all right. So it's an average question, which means you're going to use t-test for a population mean. So we come up here. That's where we get t-test for a population mean. All right. So now we need HO and H1. So HO is the null hypothesis. The null means zero. It's like your check is null and void. It's worth zero. And so that's HO. Null is just a fancy word for zero. So the null hypothesis, as it says in the notes, HO is always equal. Notice, is it going to be P or mu? Well, not P, it's not a percentage question. It's mu, and that's the Greek M. Looks like a U. That one is actually U. It's the Greek M for, whoop, I'm sorry, I went too far there. Greek M. So this is going to be mu equals. It's always, HO is always equals. Okay. And then the other one, H1, is going to also be mu. Now it's greater, less, or not equal. See how it says that in the notes? So H1 is greater, less, or not equal. And it's mu, not P, because it's not a percentage question. It's an average question. So HO is always equal, and H1 is greater, less, or not equal. Which one? Well, if it says greater, it's greater. If it says less, it's less. And if it doesn't say that, it's not equal. What did you see? Did you see anything in the words that said greater, less, anything like that? Well, is the mean average time to spoil greater? There it is, greater. So greater. So there it is. Greater than what? Greater than what? Greater than 6.9, because that says on average bananas last 6.9 times, the 6.9 days. Is the average time greater if it's hung from the ceiling? Is it greater than 6.9? And if 6.9 goes there, then 6.9, whoops, I thought I changed my color. Come on. 6.9 goes there as well. These are always the same number. Different symbol, same number. Again, how am I getting that? It says the average is 6.9 days. Is the mean time greater if the banana is hung from the ceiling? Greater than 6.9. And so basically you have the two attorneys, the HO attorney saying the average is equal to 6.9, and H1 attorney saying, no, the average is greater than 6.9 for the bananas hung from the ceiling. They last longer than 6.9, and the HO saying, no, they're just equal to 6.9. They're the same as the bananas you don't hang from the ceiling. So who's right? Who's got the evidence? Well, the calculator will tell us we just have to take this data now and stick it in the calculator, and the calculator will tell us. So let's go to the notes. Is this a percentage question or a mean average? Again, it's not a percentage, it's a mean average. No data given. Let me change this for you. Is it no data given today? No, it's a data given, right? Did you see data given right here? This is most assuredly data. It's a list of the numbers, actually, how long those bananas that were hung from the ceiling took to spoil. The first banana lasted 7.4 days. Second banana lasted 9.4 days. Third banana lasted 5.9 days, et cetera, et cetera. That's our data. So what do you do in that case? So if you have a mean average with data given, go to the online calculator hypothesis test for a mean with data. So hypothesis test for a mean with data. So we'll go there. Hypothesis test, mean with data. Hypothesis mean with data. So I'm going to go there. So let's go there. So here's the online calculator. That's number, what is it? Number 15, hypothesis for a mean with data. So 15, Go there. And as I go there, the first thing it wants, it's got a big data box up here at the top. See that? So I got to paste data in there. So let's go back to the problem. And I'm going to highlight the data. Have I lost it? I think I've totally lost the data. There it is. There. See how I've highlighted with my little mouse that data, and I'm going to copy. So I'm going to copy that data. You can hold down, highlight that, hold down Control and hit C to copy that data. Highlight that data, copy it, and then go back. Whoops, that's the wrong button. Go back to the online calculator. That's not the online calculator. And there it is. Put your cursor in the top there and paste it. Hold down Control and hit V for paste. For mine, I'm gonna have to use my mouse. And there we go. Paste the data. It's already got the commas. Don't worry about removing the spaces. They're fine. There's the data. Now we've got to fill in sigma over here, I think. No, we don't. We don't even have to. We don't need sigma. We just need mu zero, I think. Let's go back and see. I can't remember. So what did it say? Did it say anything? No, they didn't say sigma, but they did say mu zero. Let me fill that in for us. So what are we going to do with mu zero? Remember what that zero always means? It's from H0. It's the number. So it's going to be 6.9. So 6.9. It's the number from H0. That's what that little zero is supposed to remind you. Go to the H0, grab the number. So mu zero is 6.9. That's all we need to fill in. Mu zero right here, 6.9. There we go. Don't mess. Oh, and you got to do the radio button. Let's go back. Which way was the radio button? I should have done that. So with the radio button, that's always from H1. You just grab whatever H1 has. Greater. So that's going to be greater. It's the same as H1. So the mu zero is always from H0, and the radio button is always from H1. So it's going to be greater. Let's go back. Greater. So see me choosing the radio button. I'm going to choose greater. Don't worry about that sigma over and left. Just leave it blank. Don't worry about it at all. You can read that at the top. He says, don't worry about it. I'm going to hit calculate. Boom. There's my X bar X. All I really care about is the T and the P. See, the T is 2.539. The P is 0.129. Let's go back, see if those are right. They are. They are. Good. There's the P. They rounded it. 0.130. There's the T. We got them right from the calculator. The T and the P. Now it's time to draw some conclusions. And so now we come on in here and we go, all right. So the P value right here, 0.013. Oh, that's P value. And what was the alpha level? Don't remember up here. So, there's alpha 0.1. So alpha 0.1. Now that's not 0.01, that's 0.1. Which one of those is bigger? If you're not sure, come over here and write them down and line up the decimals. There's that one and 0.1. There's that one, huh? So just fill in zeros. Which one of those is bigger? Well, this one. This is like 1,000 compared to 130. So that, remember, the wide side of the symbol is open towards the bigger one. Remember the way the greater than, less than symbol works. The wide side is toward the bigger one. The narrow side is the smaller one. So the 0.1000 is bigger than 130. 1,000 is bigger than 130, right? Line up the decimals. See how I lined up the decimals to make sure I knew which one was bigger? So this one's bigger. So that means the p-value, this one, is smaller. So what does that mean about our conclusion? We come down here. If the p-value is less or greater, which is it? It's this one, right? Our p-value is less. See what I'm saying here? Our p-value, this number is less. P is less, meaning low. We call that low. And so the saying we use in that case, when the p-value is less than alpha, when the p is low, the null must go. And then it means keep H1, strong evidence. So we come down here, we go, all right. So I'll write that saying. It's a good saying every stat student should know. When the p is low, HO, which is the null, must go. Go where? Well, we mean go away. So is our p-value low? Yeah, p is less, right here, it's less. The p-value is less, it's low. So the HO must go away. That means reject HO. Bye-bye HO. So it says here, reject the null, reject HO. So if you're rejecting HO, you're keeping the other one. You're keeping H1. Remember, these are two attorneys, right? And we were deciding who we believe. HO was saying it's equal to 6.9, and H1 was saying, no, no, it's greater than 6.9. Who do we believe? We keep H1. We say the evidence is on the side of H1. And also, if you notice, it says keep H1 strong evidence, right? So strong evidence, we come back here and say keep H1 strong evidence. And that's right here, strong. The evidence is strong. Finally, what does that mean about our conclusion? So our conclusion is that for bananas hung from the ceiling, the average time to spoil is what? Well, it says greater than 6.9. How did I come up with that? Well, because we're keeping H1. And what does H1? Let's go back to H1. What does he say? The average is greater than 6.9. Greater than 6.9. We believe the evidence is on the side of H1. And he says greater than 6.9. So when all is said and done, we do believe that hanging the bananas from the ceiling makes them last a greater amount of time, greater than 6.9, which is the average for all bananas in general. Hanging them from the ceiling makes them last a greater than 6.9 time amount of days. The evidence, this data from these bananas was strong evidence, right? Because the p-value, remember, p-value is the probability of luck. The p-value, the probability of luck was low. P-value, probability that the sample data was just luck. Like maybe you just got some lucky bananas. Well, no. The p-value came out, and it was p times the probability that the sample data are just lucky. No, came out 0.130. That's low. That's a 1% chance of luck. That's pretty low. We're like, no, there's a low chance that all those bananas came out lasting that much longer. There's a low chance we got that lucky. So we don't believe it was luck. We really believe those bananas do last longer. We believe the evidence that they last longer when they're hung from the ceiling. And so there we go.